All right, so I want to welcome you to the final session of our conference, and it's going to be on the subject of bio-based products and materials. And we're going to be focusing on the sector that that some of the speakers, some of the people in the audience were talking about at the end of our last section, which is the private sector. What is business doing? How is it innovating in this area? And what are the challenges that people in business who are starting to move into this green chemistry, green materials, green products space? What are the challenges that they're facing? How are they overcoming them? How are they working in their value chain to overcome those challenges? And our focus is on bio-based products, and we're very fortunate to have speakers from companies at different points in the value chain. So I'm going to introduce our speakers, and then they'll speak. And after they speak, I will have some follow-up questions, and then we're going to open it up for discussion. And our first speaker speaks from the position of the retail interface with the end consumer as well as suppliers position. Roger McFadden is currently the Vice President and Senior Scientist for Staples Advantage, the business-to-business division of Staples. And he's a charter member of the Green Chemistry Commerce Council and currently chairs a committee to advance green chemistry and the EPA Design for the Environment Formulator initiatives. And he's also a member of the California Green Ribbon Science Panel. Our second speaker, Drummond Lawson, speaks from the position of Method, a leading innovator in sustainable cleaning products. So he's one step further up the value chain and or back in the value chain, however you want to put it. And he's the director of sustainability at Method, and they're developing these products and creating a market for them. And he's an environmental chemist by training, and his role at Method involves combining material science and green product innovations with user-centered product design. He also coordinates Method's supply chain sustainability program, engaging their supplier base to develop zero-waste manufacturing practices. Mark Bunger is now is at the kind of has a bird's eye view. He is a research director at Lux Research. It's a consulting firm. He currently leads Lux's alternative fuels, bio-based materials and chemicals, and targeted delivery practices. He joined Lux with 14 years of business strategy experience, both as a management consultant and technology analyst. And so he's got an interesting perspective on all this. And Steve Hahn, our final speaker, is a senior research scientist at Dow Chemical's Ventures and Business Development Group. It's a new ventures group, where he leads Dow's effort to identify emerging strategically aligned chemical and material business opportunities. And he has he's a chemist. He has a BS in chemistry from Michigan Tech and an MS in chemistry from Central Michigan University of Michigan Molecular Institute. He joined Dow in 1982 and was a research scientist for many, many years, and holds 30 U.S. patents, and was named a Dow Chemical Company Inventor of the Year in 1990 and 1996, and was presented the Dow Chemical Company Michigan Scientists Organization Excellence in Science Award in 1999. He's published lots and lots of articles and has been a visiting professor in various places, and was a recipient of the American Chemical Society Cooperative Research Award in 2008. But now he's gotten into helping Dow identify these new business opportunities and helping them move into that, which is a challenge. So without further ado, I'm going to invite the speakers up, and Roger's going to go first. Thank you. Please welcome Roger.
this works? Yes, it does. Well, first of all, I wanted to thank all of you for inviting Staples and myself to be here today to not only share just a few minutes worth of kind of information from our perspective in this area of green chemistry and bio-based products, but also I'm the picture of the deer with the big ears because I've been listening today. And many of you have done this much longer than I have, and even though I'm old carbon compared to many of you who are much younger than me, I really believe that it is a collaborative effort, and it will take all of us in this room and some who aren't here to accomplish the things that John and others today have talked about. So thank you very much for this invitation, and I do have to apologize. I'm going to have to catch an airplane, and so I will not be able to stay through the entire, all my colleagues' panel presentation. So when you see me leave, please know it isn't because I'm upset or angry. It may be that I've done such a terrible job here I was embarrassed, so I needed to leave. So, all right, so what's this all about, this bio-based products? And you know, what matters most to customers? So what I'm going to talk about for the next few minutes isn't necessarily science in the pure sense. It's more practical in the sense that what are customers asking for today from a very large company? We're $20+ billion enterprise in 27 countries. We have about half of our businesses are Staples retail stores, which many of you are familiar with. The other, actually a little more than half, is made up of our business-to-business relationships. That is, we sell to the largest Fortune 500 companies in the world. And some of those companies we sell to are our customers, but we're their customers as well, some in this room. So they provide products to us, and we sell their products, and vice versa in many cases. So it's important for us to understand this supply chain is so important in any business. We must have good relationships with our suppliers and with our customers to be successful. That isn't always easy to do, particularly when we're trying to affect change and trying to move people away from status quo thinking like we are wanting to do in this area of green chemistry. So this area of bio-based products at Staples is important to us. We sell over 500,000 products in our supply chain today. We have more than, we've identified, we think, in the neighborhood of 10,000 or more materials that make up those products. And we do business with thousands of suppliers that are scattered across this globe, not only in the United States, but in other countries as well. So you can imagine the complexity of the supply chain itself. So when we begin to tackle something like these, the idea of bringing bio-based products into the business, we have some real questions we need to answer. And I'll share with you some of those questions in a moment. This is what matters today to our customers when they talk to us about this area of bio-based. First of all, they want a clear definition of what it is. Many of our customers ask us for bio-based materials and frankly don't even themselves have a clear definition of what that means. They don't want performance trade-offs, so they're not willing to give up and sacrifice performance or cost or health and safety. They want to reduce the consumption of oil because they've all followed what's been going on the last couple of decades. They want them to be more sustainable throughout their entire product life cycle, and they want them to be as nearly close to cost neutral as possible. Bio-based is not a synonym for safer or better. And that's something we have to come to grips with, that just simply because something comes from nature or from a plant doesn't mean that it should get a pass. We need to look at the full picture of the product. Too many marketplace definitions of this particular issue, and that creates the opportunity for greenwashing. Genetically modified organisms are important to understand. Are those included in these materials? Rapidly growing species that are invasive. We have looked at alternatives for pulp that comes from trees, for instance, in some of our paper operations. And we look at these alternatives, and then when we begin to look at LCAs, we begin to realize real quickly that some of these materials look very good on the surface, but then when we dig in deeper, they fall apart and they don't meet our sustainability objectives. The desire for sustainably grown biomass, a lack of adequate recycling and composting programs to be able to handle these type of materials, and the lack of adequate labeling. So I would just ask, what are we willing to trade off here? What are we willing to trade off? And will it require trade-offs, or are there other ways to do it? For instance, what if a product is recognized as a bio-based material but contains chemicals that are carcinogens or reproductive toxins, or those chemicals have to be used in some way to produce the product that this bio-based material is in? Does that matter? Is that important? It's important to our customers because a growing number of those customers are saying, we don't want those kinds of chemicals getting into our homes, into our businesses, into our offices. So again, I just challenge you with these questions, and we challenge our suppliers with questions in 3 areas related to this. 1, what are your feedstocks? 2, what's your manufacturing and use processes? And 3, what's the end-of-life impact? So we're really going to look at those 3. So when we meet with our suppliers today, and they bring us products that they claim are bio-based, we don't just accept willy-nilly the claim of bio-based and then insert it into our supply chain and then begin to capture metrics around the fact that we're selling, X amount of % of bio-based materials. We're very interested in understanding the legitimacy of that particular claim because we are putting our name, if you will, on this to the consumer, and we need to be sure that it's grounded on sound science. So what's the bio-based content, feedstock type, and source location? Where's the source coming from? What did it replace? Biodegradability of all materials in the product, additives and blends. What are we using in the way of plasticizers in the case of plastics? What are we using in the way of these additives, colorants, fragrances, whatever they might be? What are those in the bio-based material? Recyclability of the material or compostability of the material. Performance in the product that that it was intended to be in the case of materials brought to us for use. By the way, I didn't mention about 1/3 of our business is made up of our own Staples brand group. These are products we design and own the formula for. So we have a team of engineers, primarily engineers, who design products in our various business sectors that make choices about materials they're going to use in the products. And so they're the ones that we want to bring into the discussion when it's this. So when we're looking at a bio-based material, we want to make sure it performs for our intended use. So what kind of questions do we ask our suppliers? Is the biomaterial sourced from sustainably grown and harvested croplands or forests? We don't just want a yes or a no or a real quick answer. We really would like to see the data on that. Is the biomaterial or product manufactured without hazardous inputs and impacts? We want to understand as much as we can without violating their CBI. We want them to explain to us their processes, their traceability. Is the biomaterial and product safe and healthy for the environment and human health during use? The worker safety is important to us. So even though it's called a bio-based product, if it is an asthmagen or it does create issues in human health, we're much less likely to embrace that type of material than one that wouldn't have that. And is the biomaterial designed to be reused at the end of its intended use? In the area of feedstocks, how does the production of your feedstock for your bio-based material affect the environment? Is the feedstock genetically modified? These are questions we actually ask to the suppliers, and they actually respond to us when there's bio-based claims. What is the identity of the pesticides that are used, if any, on these particular materials? And is there any chance these could carry over into the product itself? So it isn't good enough just to be bio-based. If there's pesticides that are being carried through the process and they aren't extracted in some way out of the product, we're less likely to want to choose those. What sustainability standards and reportable metrics do you use for production of your bio-based material? So we're wanting to go beyond just the claim of the material, if you will, and look at the more the larger view of life cycle. In manufacturing and use, how does the manufacture of your product affect the environment and human health? Again, we just keep asking that question at each stage of this so they understand that human health and the environment is an important factor for us. How does the manufacturing of your product using affect of the workers? So not just the environment and human health in the production, but also in the use of the product. And how do you characterize the waste generated from your manufacturing of this particular item? That's important to us to understand. And then compare that characterization to the non-bio-based material you're replacing. So when they bring a product to us, they're likely replacing a product in our particular supply chain now and using that as a value to us. That's okay. All they need to do is make the case that there are these benefits in their particular product when compared directly to what they're replacing. End of life, are there, can this product be recycled? We've seen some of the bio-based plastics, for instance. There aren't any really readily recyclable places for anyone to take those. So the fact that they're recyclable is one thing, but if our customers who buy these from us ask, to send these back and they find out that they're rejected, they're not very happy, particularly if they live up in the area of the country where I live in Oregon. I'm an Oregonian just north of here. You've probably heard of that state. We create a little noise, not quite as much as California, but occasionally we do a fuss or two. But I know that I would, we do curbside recycling there. People would be very infuriated if they started putting materials out in there and they were rejected and left. I mean, that wouldn't be very good. Does the product contain chemicals that contaminate the recycling stream? That's so important, isn't it? Because we just assume, I guess, that the recycling stream's just pure, right? I mean, if you just put stuff in the recycling stream, it's just going to be clean. Don't worry about it. But we do know that in paper recycling, for instance, we end up with bisphenol A. Where does that come from? Thermal paper receipts. So people don't know the difference between a thermal paper receipt and a normal piece of paper, so they throw it into the blue container and it ends up in our recycling stream. And so are there special concerns about the composting of this product, like plastic bottles or plastic bags? We want that characterized to us. And then I'll end with the same slide I started with. But then if I might indulge you, I want to read something to you and see, there's a lot of smart people in the room. Let's see who can tell me who said these words, and maybe even when. The choice, after all, is ours to make. If having endured much, we have at last asserted our right to know, and if knowing, we have concluded that we are being asked to take senseless and frightening risks, then we should no longer accept the counsel of those who tell us that we must fill our world with poisonous chemicals. We should look about and see what other course is open to us, unquote. Who said those words and when?
Nixon, 72.
Yeah. What a dream. Boy, you are dreaming or something. That's right. Very good, excellent. Rachel Carson said those words, Silent Spring, 1962. I believe those words are relevant today and maybe even more relevant today. And I'll leave you with this. Can all of us in this room imagine what would have happened if Rachel Carson would have had the social media? Thank you very much.
Did you say who's next?
Okay, our next speaker is Drummond Lawson. Please welcome him.
Hello. I think what I'd like to do is talk a little bit about how Method tries to make green chemistry a vector for product innovation. So how can we focus on turning this into something relevant for a business to make better? So how many people here know who Method is? Most. Almost everybody. Sweet. Who doesn't know Method is? We should talk later. We'll get a chance to chat over the poster session. So what I wanted to talk about was how we treat green chemistry in our product development process, how that fits into making our products, how we're trying to engage with our suppliers, and ideally make a little bit of meaning for our product users. I think the key point that I'd like to make here is that bio-based is one of many attributes. It's one of many determinants of the sustainability of the products. It's one of the many factors that contribute to a product's environmental and human health profile. And I think a mistake is often made in our category and in other categories to say that bio-based is a surrogate, right? Much as Roger had said, that it is a surrogate or a proxy for a sustainable product or for a safe product. It's one of many factors, so just a caveat that I will focus on speaking about how we are using safer chemistry and on using bio-based chemistry, but understanding that that's one of many factors that determine the safety of a product. And the safety of the product or the quality of the product is only one of many factors defining the footprint of an organization. And again, to be very focused on all these different pieces of the puzzle rather than just one. Our approach is informed by, well, by many factors, or by many, I guess, many visions, but one of the big ones internally is cradle to cradle. So this isn't required onboard reading for people when they come to Method. It's funny, when you're a chemist and you read cradle to cradle, you're like, wow, cool, this is like, you know, like a novel. Like this is, you know, like a comic strip version of chemistry. Like it's great, and I used to work for Michael Brown Goddard, and I think there's some very good content, but you think of it as like pop reading. And then when you hand cradle to cradle to a brand manager, they're like, oh my God, this is a crazy chemistry textbook. And you're like, no, those look very different. This is the accessible version. So it made me think that green chemistry courses in a business school curriculum, they'd have some challenges in terms of their readings. How cradle to cradle is translated internally is, well, we're a cleaning products company, so the vision is translated pretty cleanly to what we're making. No pun intended. We make bottles that live within a technical cycle and formulations that live within a biological cycle. So we're looking for any materials that are going into our formulations to be compatible with environmental systems downstream and to come from, ideally, from a natural origin. The way that we think of this at Method, actually, I'll skip a slide ahead to look at our materials assessment. We work with an external materials assessment partner. EPEA is based in Hamburg. Their sister firm is here in the States, is MBDC. And they complete all of the basic research for us, kind of the nuts and bolts, very similar to the framework that Lauren showed earlier today on, you know, I think actually the 14, how many endpoints did green screen have? 18, so we're looking at 4 fewer endpoints. They're not big ones, don't worry about them. There are 14 endpoints that encompass many of the same factors. I guess we're rolling up a couple of them. But acute and chronic endpoints, environmental fate, ecotoxicity. And this is the homework that's done in any material that comes in. We have this external partner to do this that codes things into a green, yellow, red. Gray is the data gap, so a very similar framework, and I think there are probably a lot of compatibilities with how the cradle-to-cradle framework evaluates materials and how green screen does. So that's a great example of one of those conversations born at conferences like this that lead to hopefully better practice and more harmonization in the future. We get each material that we're looking at developing. EPA will review those and give us a code back. This is how this is translated into usable product development information. That we can then apply in a new product development process. I think that this is just a close up on what those factors are. There are a lot of the same ones that we heard earlier, but this is the specific information that's actually then incorporated into choosing which material. In this case, a surfonic surfactant. This is actually just the glycol ether that's used as a solvent for the surfactant. We've seen some interesting movement in the last couple of years in novel chemistries, and this has actually been, I think this is one of the greatest surprises we've seen at Method, is the amount of new chemistry coming to the market from startups. Sagetis is one that was mentioned earlier, Minnesota-based solvents manufacturer or green chemistry manufacturer. I can maybe dive into that case study during the panel rather than talking about it now. But we're seeing this progress at an impressive pace in the last couple of years. Actually, coming back a couple of slides. we're partnering with suppliers across a couple different areas of functional chemistry. I think what we saw, that the evolution of bio-based chemistries coming into cleaning products started off by basically substituting a couple known environmental hazards. So we saw the alkyl phenol ethoxylates earlier. So finding alternative non-ionic surfactants that wouldn't have these endocrine and downstream effects. So it was basically from a perspective of solving problematic existing materials. What we've seen in surfactants over the last 2 decades was at first basically finding parts of molecules that you could derive from bio-based feedstocks. So finding the alkyl groups that were on surfactants, you can now get those from palm and cocoa oil. So you've got a same material, part of it's now coming from a natural source. We're still seeing materials like that. There are many of those, and that's probably those materials are the basis of most of the natural claims in most bio-based cleaning and cosmetics products. What's starting to arrive, and I guess what's maybe 5 or 10 years, in the last 5 and 10 years, what we've seen is surfactants and other ingredients where the whole thing now comes from bio-based feedstocks. What we're starting to see is materials where the actual molecule, the hydrophilic and hydrophobic parts of it are coming from bio-based materials from both of them, and they're being synthesized directly. And what we're starting to see, what we're getting the first examples of are materials where, we're seeing algal oil synthesis of, biosynthetic creation of, entire molecules that we can then apply and use. We're learning a couple lessons of how to work with some of these more experimental materials. I think this is one of the rare cases where being a very small company in an industry dominated by Goliaths is really advantageous. As we have a very different tolerance for risk and a lot more flexibility in trying materials that if we were 10 or 100 times our scale, we'd be far smarter than putting those materials in our supply chains when there might not be an available supply in a year or two. But at our scale, that's a much more manageable risk. So it's a perfect example of where we can use that agility to our advantage. We've had a couple of those in the last couple of years that have worked out really well, that have offered a degree of differentiation, have offered novel performance. A lot of this comes from the kind of the philosophical perspective that the best way to make green products that people actually get excited about and actually want to use, whether they are really convinced of the product's sustainability or whether they really care about the product's sustainability or not, is instead of making green products by taking an existing product and stripping away the bad parts, you should make a green product by making it out of green materials from the start. And that's really what we're trying to do with the EPEA research here, is build out that palette of safe materials. And there are certainly a lot of gaps in it. I talked about surfactants and the origin of, or kind of the evolution of bio-based materials and surfactants. We're starting to see, or we have seen, a number of really good solvents in the past couple of years. A couple chelating agents and dispersants are finding good substitutes for acrylic acids and other petroleum-based materials. So seeing that kind of evolution push forward, but there's still a lot of holes in it. Preservatives are one thing we struggle with a lot. We'd love to find more benign preservatives. Bio-based would be a nice thing to get to at some point in the future, but just preservatives that meet our existing toxicological profile. Of course, understanding there's always going to be some inherent toxicity for a preservative, for a biocide. But I guess there's the challenges in this are finding a way to be able to articulate what those data gaps are, what the material gaps are, identifying what the data gaps are in the existing materials, and getting that communication to work better. So this is why I'm excited to see that is beginning to be a bit of a critical momentum of other companies asking suppliers for the same pieces of information, chemical suppliers starting to see the necessity of actually furnishing this information, and companies starting to understand how to use that to drive more informed product development decisions. So I think I'll leave the rest of it for the panel. I just wanted to say that it's been really interesting to see the references to the 12 principles of green chemistry today, picking out the different ones that mean different things in different applications. It reminded me of some other principles we speak of at Method, which are the Dieter Rams 10 principles for good design. So I think we could get a very interesting list of the 22 principles for good green chemistry design. I'd encourage people to go read those ones and see where they can be made to support one another.
Okay, thanks very much, everybody. My name is Mark Bunger, and I'm a research director here at Lux. If there's one thing that you remember about my talk today, it's really this second line here. It's the end of the beginning, and that might sound controversial or provocative in what seems like a very nascent field, but I'll show you a lot of data points based on our research that show that this is actually a maturing field, and it's one where commercial applications are really starting to happen and are the next big wave. So a little bit about Lux Research, if you don't know who we are. We're a commercial research firm, so we don't have labs, we don't have beakers and test tubes and things like that, but just about everybody on our research team has been in that environment before. So we're a small company, started in 2004. We have about 75 employees right now, and on the research team, we're covering these areas that you see over to the right. Advanced materials, which would be catalysts, composites, nanomaterials and things like that, alternative fuels, bio-based materials and chemicals, and a number of other technologies that are really, right now, leaving the lab and starting to enter commercial applications. So our people, again, are scientists and engineers, for the most part, that have worked in these areas, that have worked at places like Sygetis, but other types of companies like that, or like General Electric. And we apply that scientific knowledge to these questions. These are areas where there really isn't a commercial track record yet. You can't be like a Wall Street analyst and say, well, revenues have been like this for the last 10 years, and we think it's going to be like this next year, next quarter. These companies and these technologies often have no commercial record whatsoever. And our job is to help our clients, which are, as you see, we have about 150 clients all over the world. They're generally large companies in materials and energy and manufacturing, and they want to find the technologies that will help them make a better product or be more profitable. And our job is to help them suss those things out. So we do that with a lot of direct interaction. I'd say we all are nostalgic for our time in lab and like to go back and spend time on the factory floor or talking with the scientists that are working on these things and really getting a good understanding of where these fields are going and what that means for, again, for the commercialization of those technologies. So I'm going to show you a lot of data from our research, but I don't want to dwell on any one particular thing just in the interest of time, because it really all tells the same story. Like I said, it says that this field in the last 5 or 6 years has gone from very much a scientific enterprise to one that is now very much commercial, as we just saw in the last presentation. And seeing a company like Staples or Method in a green chemistry conference back then would have been really unusual. Maybe not Method, but certainly Staples. Chemistry was not something that was really core to what they do any more than, say, quantum mechanics is today. But it very much is now, and we see that around the world. So these are some of the types of companies that we cover and interact with. In other words, we're looking at the commercial activities that these companies are doing. Startups like Sygetis isn't on that list, but that's a typical company in our coverage. Solazyme, a local company here. LS9, another local company. Gevo, Synthetic Genomics. The mid-sized companies, NatureWorks has been mentioned. Novozymes, Genencor, now been bought. And then some of the larger companies around the world, too. And this is, the mention of value chain was made early on, and this is really how we look at these technologies. They usually start out in a lab, they get spun out by a professor, maybe funded by some venture capitalists, that company grows, and it reaches a certain point of viability where it gets acquired or it goes IPO. And our job is to track them across that space. So these are just some of the types of technologies we cover within the bio-based chemicals and materials area. So you saw those 17 areas that we cover. We're diving down now into the bio-based materials and chemicals and the very closely related alternative or bio-based fuels area. A few more of the technologies and the applications that we look at. One thing that, by the way, I don't think has been mentioned enough, except in the last presentation, is packaging. So a lot of the products that we think about as should they be renewable or not, we forget that there's a whole package that might actually weigh as much as the product or might take as much material and much energy as the product and have a much shorter lifetime. So those are the types of things where we say there's a real opportunity in packaging. What can we do to make packaging more renewable and get a lot more bang for the buck? So this is a very complicated slide. Like I said, I don't want you to get too much into the details. I'll just tell you this is a plot of a number of companies that are in what we call bioprocessing, which is fermentation, synthetic biology, areas like that. They're taking sugars or other bio-based feedstocks and converting them enzymatically into some other chemical intermediate or even end product. And we rate all these companies on technical value. There's a scorecard behind that axis, and business execution. There's a scorecard behind that axis. And give our clients and people like you what we try and think of as if each company is the forest, or sorry, the trees, we want to give you the view of the forest as well. And what you can see when you look at this is, first of all, it's a very, very, very crowded plot. This is one, you can tell by the fact that we've had to squeeze so many things into this. We didn't design the plot with this many companies in mind. When we started out, it's a few dots. And those dots grow. They shift from the lower left-hand corner where they're low on technical value, low on business execution. They get more and more mature, and they kind of progress up, almost like if you've seen those, the lifetime of a star, how they move through cycles. Companies and entire industries move through these cycles. And the fact that this is so crowded, there's so many companies that are up in the high technical value, high business execution, have a blue, which is a positive take. That tells us that this is a very, very mature industry. It's extremely difficult to enter this area with a new technology because you've got all kinds of incumbents that will outcompete you, that might have IP that will prevent you from entering. They've got partnerships that are exclusive or have some kind of essentially constitute a barrier to entry. So again, the details we can get into, but the main point is this is a very mature space. More evidence for that is in the venture investments in the space. So these are two charts that show the number and the value of venture investments in bio-based fuels and materials and chemicals companies since 2004. So you can see that there's a peak in about 2010. This is from late last year, so 2011 wasn't complete. But we knew for sure that 2011 was not going to reach up to what 2010 did. You can also tell by looking at the distribution of the stages of venture investment, A, B, and C, and D rounds. Those are essentially the lifetime of venture investment, an initial seed round, and then they get bigger and bigger as time goes on. So a D round is generally the last round of venture investment that a company gets. And as you can see, the shift has been from a lot of A rounds in the beginning, where you have young companies that need $10 or $15 million, to a lot of a much bigger proportion of D rounds at the end, where they might be getting $60 or $100 million. So you don't get much more than that in venture investment. And when you start to see the number decline and the shift towards those later stage rounds, you know that this field is pretty much wrapping up. Okay, it's getting mature. We need to know that because we need to look for other things to cover. And our clients need to know that because it's going to affect their investment decisions. This is another chart that, again, I'll explain the concept. The details are unimportant. The story is the same. This is a map of the companies and the partnerships, the relationships between those companies since 2005, again, in this technical field of bio-based chemicals and fuels. So if you look at 2005, each dot, that's a company. Each line connecting one company to another is a partnership. It might be a licensing deal or an investment or something like that. So you can see in 2005 to 2006, the number of entries and entrants and the number of partnerships goes through 2007, 2008. And in 2008, you see there's this big cluster that forms. And you can look at social network analysis. It might be, middle schoolers turning into seniors in high school. It might be an ecosystem. What we see in social network analysis is there's a lot of parameters you can use to quantify these developments. You can see that when that cluster forms, it becomes the central cluster that everybody else needs to partner into. As you can see by 2010, and today, just about everybody's part of that central cluster. The vast majority of companies that are in this space are networked somehow with other companies in the space. And again, as a new entrant, if you've got a great idea in your lab today, you've got to think about this whole cluster and how you're going to work into it, not just is my thing going to work in the lab. So, and then to underscore that point, these are two charts that show the number of collaborations. Now, so what I showed you before is the number of collaborations is increasing overall, but the number of collaborations, new ones per year, has also peaked. So if you can see again, and this is 2011 and 2012, some projection numbers for 2012, when the number of new collaborations starts to decline, it's basically because companies like Dow or BASF or DSM say, we've got all the partners we can handle right now. We don't really need anything new, but we'll keep our eyes on the horizon, but right now we're going to manage the portfolio that we've got. So that might sound all down in the dumps. This was two pictures actually I took yesterday at the California Academy of Sciences, and I stuck these in a few minutes ago when at the last discussion everyone was talking about how do we get the undergraduates interested, how do we work this into our curriculum. So this is the California Academy of Sciences yesterday. The girl in pink is my daughter, and I'm kind of science dad at their school. It's a San Francisco public school, and they love this stuff. This is the way to get kids interested in chemistry, is through green chemistry today. Don't wait till they're undergrads and it's like yet another thing they've got to do. I was struck, by the way, by the similarities between green chemistry and personal, protective gear and all the safety regulations. You have to take those courses. I was at a lab at UCSF for about 6 years. You've got to take those courses. It's not part of your curriculum, but you can't be in the lab if you don't do it. Ethics. You can't do animal experiments if you haven't taken the ethics classes. And those are just as, soft, touchy-feely, job-killing, horrible communist things as green chemistry, right? But you got to do it. Get in the lab, or else you're just banned. So anyway, I hope that's a high note to end this on. There is a future, and thank you. Thank you very much.
Good afternoon. It's great to be here. It's great to be the last speaker of the day. I have the advantage of having my colleagues having covered several of the key points, which I'll maybe reinforce along the way, but it's great to be here at Berkeley. I'd also like to shout out to my fellow Minnesotans. I spent a year as a visiting professor at the University of Minnesota in 2002. Had a great time there. Didn't realize the afternoon was going to be so Minnesota-centric, but glad to see you folks here. So I'm in the Ventures and Business Development Group, and I'm going to spend a little bit of time talking about what that group does and why that gives me a bit of a platform to talk about bio-based materials. But really I'd like to give you an overview of the Dow Chemical Company and give you a little bit better understanding of what we do and why that perspective really flavors how we approach the bio-based materials challenge. So we're a big company. We're founded in 1897 by Mr. Dow, who's shown over here on the side, in Midland, Michigan, which is where our world headquarters still are. We have about $60 billion in sales in 2011, and we make more than 5,000 products, and we manufacture all over the world, 36 countries. We sell in 160 different countries, and we have about 52,000 employees. We make chemicals, specialty chemicals, advanced materials. We have an ag science business and are very deeply into plastics, a variety of different plastics. A challenge with understanding what the Dow Chemical Company does is that we make a lot of different products and we largely sell them to other businesses. So it's very difficult to go to the store as an end-use consumer and buy a product of the Dow Chemical Company. There are a couple. Styrofoam and Great Stuff are two foamed insulation products that you can actually buy at Lowe's or Home Depot. But mostly we sell our products to other big chemical companies. To give you an idea of the markets we're in and the business segments of the Dow Chemical Company, I'm certainly not going to go all through these, but you'll see the various markets that we're in. We have three big business units that speak to these performance markets: performance materials, advanced materials, agricultural sciences. At the bottom, we have our joint ventures and our basic feedstocks and energy businesses. We largely sell business to business, so we make very large amounts of material and sell them to other businesses who then convert those materials into something else and sell it to an end-use consumer. We are not back integrated. So we have to buy our raw materials, and the primary raw material we buy is natural gas. We buy a lot of natural gas. We then convert that using catalytic processes in many cases to other intermediates that we then sell to an end-use consumer, another business typically. That puts us in an interesting part of the value chain. So we often don't have a lot of control over what the cost of our raw materials coming in are. There are competition in all of the markets that we're in. People are making very similar things to what we make and selling it to the same customers. So we have a limit to the cost we can pass along to our customers. And what this means is that the margins for our business are not large. So we're happy to see 15% gross margins. Sometimes it gets down below that. And so that's something we have to keep in mind if we want to stay in business, is that we have to consider how much it costs us to buy our raw materials. And in the bio-based materials space, that's very important. We also have to understand who we're selling to and how much money we can make selling those materials. I will also point out that we do have a bio-based material business right now. Dow Wolf Cellulosics, which is under the Functional Materials Group, is a business with more than $1 billion in annual revenue. They take cellulosic materials and convert them into a variety of alkylated cellulosic materials, which we sell into food applications, drug excipient applications, more than $1 billion in revenue, and we've been in that space for more than 50 years. So using bio-based raw materials to create chemicals is not exactly a new thing. The group that I'm in is called Ventures and Business Development. So we're the group that looks out for the corporation and analyzes emerging opportunities that we think Dow ought to be paying attention to. This is a group of people who are both technical, business-based, financial-based, engineering-based. We look at something like 50 new opportunities a year, and we do a process that's very similar to what Lux does. We look at the viability of that individual opportunity from a commercial perspective, from a business perspective, from a cost perspective, and we have pretty deep capability to do that, especially in the chemicals and materials space. And the reason we have to do this individually for each opportunity is that there is no way to cut across all of the types of opportunities that we see. And this is an important point, and especially in looking at bio-based materials. It's not a one-size-fits-all opportunity. You will not see the Dow Chemical Company come out and say we have a program that speaks to bio-based materials. Every market we look at has its own cost situation, its own customer base, its own market that has to be addressed. And so these groups take on individual products, individual markets one at a time, and makes a decision and recommends it to senior management based on what we see in that market for that material. That being said, this group goes through about 40 to 50 full studies a year with a full team of scientists, engineers, commercial people, legal people, sometimes business people, environmental health and science people, and comes through it with a recommendation. Of those 40 to 50 studies that we do a year, probably a third to a half of those, especially for the last 2 years, have been on bio-based materials. The amount of innovation that we've seen, and I think Mark spoke to this a little bit, a lot of people are working on biomass to chemicals. They're convincing algae or some other microbe to convert sugar into chemicals. A lot of people are trying to make bio-based plastics, and this can take a number of different forms. It can be making a bio-based monomer that's then polymerized into a polymer, or making a polymer directly from some biological source. So there are a number of different opportunities here which are very different from one another. They speak to different markets. They have different cost bases. You have to look at these one at a time and make a judgment about whether that makes sense or not. So in addition to the Dow Wolf Cellulosics business, which is already bio-based, we're gradually moving forward in some of these spaces. Not a lot, because we typically go after large opportunities. We're a commodity chemical company. For us, 100 million pounds a year is a relatively small business. We do a lot of things at a billion to multiple billion pounds per year. And scale makes a difference. These things tend to be capital intensive, and so a lot of things don't make sense until you make a lot of them. And I think that's also speaking to part of what Mark was saying, is that having people break into these businesses can be very challenging depending on which market you're speaking to. So a couple of recent announcements to point out a couple of, it turns out, very different bio-based material opportunities. Again, this speaks to the differences in what these look like. One that was announced just yesterday, I'm sure in anticipation of this conference happening. We entered into an agreement with Solazyme, which is over in South San Francisco, and Solazyme is working with us to use a biological method to make a dielectric transformer fluid. And this is a business opportunity in our electrical and telecommunications business. And again, we're working with Solazyme, but what we are here is an end-use customer. So we're defining what the product specifications have to be and what the cost has to be, and then challenging Solazyme to deliver a product that meets those specifications. A relatively small volume market, but a meaningful one for us. Another one that was announced last year is that we're building a plant along with Mitsui in Brazil to take ethanol and convert that to ethylene, and then convert that ethylene into polyethylene. And this will be a biopolymer plant, probably the largest one in the world when it comes up. This is the kind of thing that's a little easier for us to take on. We have a lot of capability to handle ethylene and to polymerize ethylene into polyethylene. And so this minimizes our risk. We have a lot of capability to do the polymerization. We know what the downstream markets for the products look like. And so really this pushes the risk profile back to the very beginning of this, which is growing the ethanol in a cost-effective way in the first place and then dehydrating it. So a couple of examples of the kind of things that Dow is doing. We're doing a little bit. I think that in the next few years you'll see us doing more. But again, it's going to be it's not going to be an across-the-board approach. It's going to be a case-by-case as the markets are identified and make sense for us to move forward. So with that being said, I'm again thankful for being invited, and I look forward to the panel discussion.
Okay, so I just want to, we are hearing about all this progress that you're making, and it sounded really great, right? And I wanted to go back to something that Roger said, which is that there are trade-offs. And I know that you're building, you're creating markets for these new materials. And you're doing it in a world in which everybody wants the perfect green chemical, not the good green chemical. And they want something that doesn't cost any more than existing products. And I want to start with you, Drummond. How is Method dealing with this trade-off, given that you're, there has to be costs associated with what you're doing? Could you talk about that, how you're working with your suppliers and what you're doing now as opposed to what you're going to be doing down the road to try to deal with the issue of some of, are you doing life cycle analysis, and are you trying, I know you do that, and you're working on all these areas and you're optimizing, and what kind of challenges are you facing, and how are you dealing with it?
Yeah, absolutely. So, one of the biggest challenges, I guess, that we face is a lot of the time with the newer materials, there's not the available literature to perform these materials assessments that we do with, legacy materials that have been around for a long time. So kind of that closer end of the innovation spectrum on, bio-based or renewable chemistries is you're finding different ways to make the same stuff. And in that case, that's relatively easy. There's not a whole lot of challenge there of completing the materials evaluation research and going through that framework and scoring it on our existing methodology. One of the things that we've struggled with is when we start to get further along that spectrum, we get completely new chemistries where there is really a total paucity of data, and we're not able to evaluate it with our existing materials evaluation framework. And I mean, that's something that we've been confronting over the last year or two increasingly. But I mean, that's a really high quality problem. That means that you are pushing that horizon, and you are getting to these materials where you have to ask those questions. We've relied a lot more on analogs to be able to understand their toxicology, and we've been able to partner with a number of these materials to a number of the material suppliers to help them through necessary testing, and environmental fate and aquatoxicity testing to help them understand what that level of information we'd need as a brand would be. We've been able to help a couple of them access export markets that they haven't really been looking at but are important for us, and be able to borrow a lot more resources from these companies than our scale would necessarily dictate, because we can be their proof of concept in the market. So I think that's trying to find where we have something valuable to offer the company. It will help us get over that incompatibility. Mm-hmm. In terms of where that's going, I mean, I think there's still a lot of materials and a lot of companies looking at different material applications. So I think we'll see a lot. I think we'll see the same question a lot over the next few years.
And how are you dealing with the cost trade-offs?
Yeah. So I guess we have a different challenge in that when you're a company that's making an entire array of products or an entire product line that aspires to sustainability, you're not saying there's not a trade-off of saying, okay, well, shall we make a green dish detergent or a conventional one that we could sell for 15% less? I mean, we're making a good product, and we have a very clear internal definition of what that definition of good is, and that is elaborated very specifically in terms of material chemistry. So we'll make it out of the right materials, and then figure out how to make the right, make that into a profitable product.
All right. And how does that come up? Surely it does come up, these trade-off issues with your clients as well. Can you talk about how it's coming up? And
so one of the biggest cost trade-offs that almost never occurs to a chemist is more about the logistics in the value chain. So there's a really profound and fundamental difference between petroleum-based chemicals and bio-based chemicals, and that is the latter are very, very decentralized and distributed, and the whole infrastructure on gathering biomass, processing it, then consolidating it to take it to some kind of a processing facility is very, very different, and the economics, therefore, are very different. So whereas in petrochemicals, we think about oil-producing nations, and it's Saudi Arabia and a couple places, we can all list 4 or 5 places that do that for us, and gargantuan refineries that look like the Death Star. They're so big you can't see from end to end. In bio-based things, it's like if you think of a sort of a 50-mile radius or so, depending on the density of the feedstock that's being grown there, you really can't transport it much farther than that because you're using more fuel to transport it than is in the feedstock itself. So it's not just an economic question in the sense of dollars and cents. It's a physical economics, if you will. It's it's a chemical equation, really. How far can I take something and still get some value out of it? So if you divide the world up into pixels that are 50 miles or so big, that's what you have. It's a very different economic problem to have to solve. And again, most chemists don't really think about that.
Yeah,
To follow up just a little bit on that, Mark makes an excellent point. One of the advantages that the existing chemical industry has is that the natural gas and petroleum infrastructure was put in place and has been in place for quite a long time, not to support the chemical industry, but to support the fuel industry. We only take less than 5% of the total petroleum and natural gas output that goes into chemicals. If that were not the case, then the capital to volume ratio would be very different for this business. And would certainly paint a different scenario for a lot of the chemicals that we look at.
And how are you dealing with the fact that you work for a giant company that makes commodity chemicals? You and I have talked a little bit about that, but maybe you could share about, you're trying to steer this giant ship in a new direction, and to some extent.
Well, fortunately, I don't have to steer it myself,
but you have to
provide advice.
Yeah.
I think one of the challenges is that we deal with so many different markets, right? So if you look, for instance, at selling an epoxy resin into a circuit board, or into a pipe coating, the people who are end-use customers for that are looking for very specific performance and don't really have an opinion about whether that should be a bio-based material or not. If you're selling a surfactant into a home and personal care application, similar to the ones we've heard about, people may care intensely. So it depends very much from market segment to market segment, just what the criteria are and how much the customer cares about that. I think the toughest one is one that Mark alluded to, and that is packaging. If you look at where most plastics actually go in the world, it's into packaging applications. And there again, some customers care very much about having renewable materials. Some don't care at all. Many that do care are unwilling to accept any degradation in properties over the product that they're buying right now, or any increase in cost. And that certainly puts you into a pretty narrow box for what you can produce.
Right. I teach in a business school, and I'm an environmentalist, and of course I'd like instant solutions to all our problems. But what I know from being in a business school is that these are problems that actually have to be solved, and there aren't easy solutions, and it takes time, and it's complicated. And are there questions?
You guys have talked a lot about bio-based options for making different chemicals. I was wondering if your companies have looked into recycling end-of-use products for things like polyethylene. I know that it kind of has sort of the same challenge of logistics as the biological companies, in that you have waste coming from all different directions and it's dirty. But I know of a couple good technologies that are out there, and I was wondering if those are high on your guys' list of ventures that you're looking into.
Just say who you are.
Oh, John Sindler. Hello. I work for Abbott.
Okay. Well, we do cover a couple companies that do plastic recycling, for example, and the issue that you touched on is the primary thing, and that's the reverse logistics. So just the same way there is with biomass, that it only really makes even chemical physical sense to transport it at a certain distance. The same thing with plastics. The collection of what is a very, very, very diverse and dispersed amount of material can sometimes overwhelm any environmental or economic benefit you get from regathering it. In some cases, you can solve that by having a technology that scales down very well. So to go back to the production side, there are facilities that you can fit in a container that you can use to process biomass into some kind of an intermediate that you can then consolidate. And then you can move that container around to where the biomass is. That's a lot harder with recycling, just to, again, because of the economic value in non-urban populations. So a place like San Francisco or this whole Bay Area, we've got the consumer mindset, we've got relatively progressive waste management companies, and they're doing a lot of that work, but that doesn't necessarily work in, say, Iowa or someplace where there's so many little sources of this material that it wouldn't make sense to reconsolidate it.
Yeah.
Nope, hang on.
Oh, okay. Well, why don't you choose?
Richard Leroff, the Investor Environmental Health Network. Question for Mark. You listed all those categories of studies that you do. Mm-hmm. Have you ever considered doing a study called green chemistry? Have you thought about whether it's worthwhile doing? Can it be defined in some fashion that will be useful to the customers you serve?
Yeah, well, so within green chemistry, this really gets to the heart of this whole conversation today is there's the 12 principles, there's the bio-based, there's the renewable, recyclable, and why is it called green in the first place? Because plants are green, right? So it has there's this one aspect of it we think about plants, but there's no real one definition. And so if you look at the technologies that we cover, there are a number of companies that specifically are developing a technology in that field, and we focus on them as the embodiment of that technology. With green chemistry, there's no, well, except for bio-based materials and chemicals and a few other areas, there's no one set of companies that has a monopoly on those 12 principles, or that they've got the technology that does this. But ones like Sygetis that you're interested in, those are companies that aren't necessarily using, some of those can use other types of materials in their process, say gasification of municipal waste. That can be a green chemical thing, but it's not, like I said, it's not that green chemistry specifically. Does that make sense? It's really a definitional thing, I guess, would be the short answer.
In a sense, I think you did answer my question, which is it's very, very difficult to put your hands around this thing called green chemistry from a market point of view. That's how I interpret what you said.
Yeah. Well, like I say, it's a little bit like safety or, say, animal ethics or something like that, where it's the field of practices. It's very, very important, but you can't necessarily embody that in something that's investable, which would be the bottom line.
Renee Sharp, Environmental Working Group. I have kind of a related question. One of the themes that we've heard today a lot is, well, how do we do green chemistry and make it a reality when we have this whole generation of people who were never trained in green chemistry, and we have this dearth of education even now? And I'm just wondering if that unfortunate reality has impacted your work in various ways, or how that is manifesting if you're bumping up into that issue.
Yeah, I think we have. I'm thinking of our formulators and packaging engineers at Method, and although none of them are trained specifically with green chemistry as elements of their education, I mean they're coming from different pieces of their background that become relevant. We have one of our formulators that worked in oxidation chemistry for most of his career, and that's not specifically called green chemistry, but oxidation chemistry is phenomenally useful when you're trying to define alternative bleaching agents to go in an auto dish formulation. So that's, you can have technical elements that you can draw from other elements of a background. And as long as you're putting the right filters on the outputs, as long as you're defining sufficiently well what you want what the target is, I don't think that's necessarily a problem. That said, it would be great if, all potential new hires came in with these principles kind of, intel on board. But I think there's a way to be able to institutionalize that so that, you have a clear definition of what a successful product looks like.
Yeah, and one of the earlier speakers talked about this as a generational problem, and I was just laughing to myself a second ago because I was thinking about a generation ago, and two for that matter. You see pictures of scientists in the lab. They've got no goggles on. They're smoking. They've got a pipette in their mouth. They're like literally sucking up the chemicals that they're going to put someplace. But stuff that we would just never consider today, and is looks preposterous. And I think that there's I think it's actually very likely that green chemistry will be viewed in the same way in the future, as we'll look back at, like, oh, they were dealing with this and that chemical, and they didn't they were in the same building as something. So I think that that'll change. And I mentioned kids. I do think that that's where you start. It's only she's going to be in college in a few years, so hurry up, you know.
Yeah, I think the interesting example in that is one of my lab supervisors right after undergrad said that they used to use benzene as a common agent in the lab to clean glassware. I was like, really? You know? He was like, yeah. And then we realized that there were applications of materials like that, so we switched to acetone. And that's great. That is a massive improvement. But then you could say, well, so what could you use for specific materials that doesn't have the downsides of acetone? So it's that that's again that spectrum.
So John Hartwig from UC Berkeley. So I'm wondering if you can give us a sense about the calculation of sort of the global impact of bio-based materials versus petroleum-based. And you made a couple of comments that made me wonder about that in terms of having to transport solids versus liquids, having an infrastructure already in place that does refining of petroleum. And we take, in chemical synthesis, as Steve just pointed out, you take off a small percentage of that. So if we ran out of petroleum, we'd be in a lot bigger problems than we would be for chemical synthesis. And then, if you're going to grow things like palm oil or seed oils, those are grown in climates where there are rainforests that need to be taken down to grow enough material to do this. So I'm just wondering, there's a lot of portions to that equation, and I think you guys have probably thought a lot about that. So can you comment on those different aspects?
I mean, I can tackle that one a little bit. Again, we have a lot of horsepower that we've put into this kind of analysis. And I think a lot of the parameters are understandable. So we look at situations where we understand what the raw material source is, how you would grow it, how you would harvest it, how much you could harvest in a year, how you'd have to process it, how much farmland you'd have to plant in order to supply a certain market. We've looked at a lot of algal synthesis, where you're starting to look at photosynthetic efficiencies and how much acreage of algae you'd have to have in order to make a certain amount of material. And these are understandable things. I mean, you can do the calculations. People have gone pretty far down the path of scaling these, at least to some extent. And again, it depends on how much you need to make and what kind of material it is, what kind of market you're satisfying. But I think by and large, the tools are in place to come to a pretty fundamental understanding of how these things work.
Yeah.
It depends on the market. I mean, where you see people commercializing, I think again, the Lux analysis was pretty nice. You see people like Alilix and Amyris and Solazyme who are making a go of it, and they're going after markets that are more specialty markets that you can satisfy using that kind of technology without having to get to scale in a huge hurry. And we'll see how fast they get there. We're seeing some success, and well, you analyze the space too, so you can agree or not. But a lot of people went after fuels first and then figured out how difficult that was going to be, how slim the margins were, and how big the scale was, and how huge the capital load is. And then they stepped back to more specialty products, which is a little bit more manageable. Volumes aren't quite as big, margins are a little bit better, and I think that's where we're starting to see some people do better. So again, it depends on the market, it depends on the scale, it depends on the technology.
I think a really big, another big mindset shift that we all have to go through is we think of Dow and BASF and DuPont as the giants in the industry. And green is really a carrot for them. It's not a stick. You might think of it as something, well, we're going to beat these guys with regulations till they make some nice green polymers for us. The stick for them, or maybe even the bear chasing them, is the SABIC. It's basically the oil-producing countries have all decided that they'd like to actually have a petrochemical industry of their own, and they'd like to capture the value of polyethylene, polypropylene, some of the more basic chemicals that they can produce, and that's chasing a lot of the bigger companies that we think of the giants in the petrochemical industry. So there's no way in the world that those things are going to go away anytime soon. It'll be decades. It certainly won't be in our lifetimes. Those companies, companies and countries have a very, very deep interest in building out their own economies with those chemicals as a basis. And these guys need help to produce chemicals and materials that can compete on economics with what's going to be incredibly cheap polyethylene, polypropylene, and everything else for as long as we'll have access to it. So oil may or may not be running out, but it is running out for these companies.
Well, the other wrinkle in there is that natural gas just got cheap again in the United States, and that's going to have a huge impact on these industries for a decade or so.
Yeah.
I guess this question will be for Lux and the Dow person. As they push more and more for the green products like the solar and more in the energy market, solar and electric vehicles, nobody's really discussed the end-of-life seriousness of the hazardous waste in lithium. Lithium batteries, aren't very recyclable. There isn't any technology that I know of is economical. There's cadmium in a lot of the thin-film solar panels, and the tsunami that happened in Japan, nobody's done the study on what kind of hazardous effect that had on the environment. So I was wondering, where you stand on that. Are you looking at that as a business, as that problem's going to exist within the next 5 or 10 years, even though a lot of the environmentalists haven't really addressed that issue? I'm that dumb old engineer.
So the answer is absolutely. I mean, that's part of the business calculation that you go into. I'll point to lead-acid batteries, which every one of us has in our car. The efficiency with which people recover and recycle lead is very, very high. If you look at materials, and certainly you make a good point, that the kinds of materials that are going into thin film solar are things you got to pay attention to. Some of those are pretty environmentally hazardous. So yeah, certainly we keep those things in mind. Part of it is those industries are small enough now that there hasn't been so much of a drive to do that. But as those industries get bigger, I think you'll see that come back around. Certainly people are talking right now about end of use for lithium-ion batteries. How do you deal with that? Starting to see some companies come to agreement with recycling entities that are going to take those batteries back and recover the materials from them. So yeah, I don't think that's lost, certainly not on us. I assume that our competitors are looking at those same spaces and getting ready to deal with those situations.
I would say the interesting aspect there that, again, some smart Berkeley people can probably help solve is we call this green-on-green warfare, where you've got two environmental ideals, even sometimes two regulatory regimes that are in direct conflict with one another. It's just the industry is at such an early stage scale we haven't seen the collision yet, but it's two trains on the track, and there's no way they won't meet at some point. So the desire to have bio-based fuels for aviation, for example, is going to collide with the desire to not have genetically modified organisms producing those fuels. The desire for solar energy or electric vehicles is going to collide with the recycling issues. Even today, you see, like in Europe, you've got a what's called the ELV, end-of-life vehicle recycling mandates that keep increasing, and it basically says you've got to recycle every bit of that car. Well, most of the metals you can do economically already. The plastics, though, which have been more and more of a component for lightweighting and environmental, those are really, really hard to recycle, and the composites and things like that people are using. So don't know how those things, there's no scientific way to say how they'll get resolved. It's a policy issue.
I'm told we could have one more question.
Thank you. I'm Bob Peoples with the ACS Green Chemistry Institute. Drummond, you put up your Cradle to Cradle book and talked about that as a platform. But I'd be interested to hear your perspectives on the fact that petroleum is going to be with us for a long, long time. And right now we pump it out of the ground, we use it once, and we put it back in the ground in another form. But there's a need for the development of technology to recover, recycle, reuse all of these petroleum-based feedstocks while we figure out how to do a transition to some balance of a bio-based economy going forward. Having lived through trying to develop the technology and build a business in the U.S. for recycling of post-consumer carpet, there are some Herculean challenges around disassembly of products, separation of materials, and then developing the technology to recover, recycle them. So I'd be interested in your comments on this.
Yeah, I think that's a good point. It's, the point is that the Stone Age didn't end because there wasn't any more stone. The petroleum era is not going to end purely because of the depletion of petroleum. There'll be, probably economic pressures more than anything else. I think the answer for us is build markets and show that you can have high value applications of recovered materials. The area we've been most focused is on packaging. Probably 85% of the volume of the packaging that we're using for the bottling resin, which is the easiest component to solve for, is coming completely from post-consumer sources. And that's a big technical challenge to solve and very big for an aesthetics-obsessed company. We need to have products that actually catch people's attention in the a hand soap aisle where nobody's paying attention. People buy cleaning products on autopilot because they're like, as a whole, as a legacy of the industry, they're not very. It's a very low interest area. So if aesthetics are a key part of getting people's attention, you can't compromise on the clarity of the bottle. You certainly can't compromise on the performance of the bottle. You can't compromise on the cost of it. So you're solving many different challenges. But the upside, I think, actually, we've had great successes even in dispersed recycling. I think it's the carbon benefits and the energy benefits of working from recycled feedstocks for PET, for example, you're saving in the order of 74% of the embedded carbon when you're working from post-consumer resin, which is phenomenal. That's a really amazing change that I'd love to be able to find in other areas of our business as well. The challenge for us is, well, you're now answering for potential contamination. You're answering for inconsistency in supply. You're answering for uncertainty in origin. So, it requires, I guess, a different capacities with the packaging engineering team, building really robust relationships with the right suppliers, and ultimately, I think the biggest impact we'll see there is if you can prove out high-value applications of these recycled materials. I mean, there's effectively limitless supply. The number that was cited before of 3% plastic, 3% of U.S. plastics, even in the highest quality plastics, water bottles, they're recycled 18% of the time. So you've got 80% of the volume of plastic used to make the highest quality, purest, cleanest plastic you're going to find. 80% of it gets thrown out immediately. So there's, there are huge opportunities for those materials. You just need to have effective markets there to incentivize their recovery. The scientist in me does not like giving these numbers out because I'm not sure of their truth, but they're certainly, they'll provoke thought. I was told last year that the number one and number two U.S. exports by mass were recycled plastic and recycled paper, going from the Western U.S. over to Asia for materials recovery. And I'm not positive that's actually true or not, but it's believable. The volume of materials that don't have effective recycling here in the West Coast, or even really anywhere in the country, that are then sent off to lower value applications to be recovered somewhere, is staggering. That's really amazing. That's like gold. Those are really high value materials that you can make usable new products, usable new packages, feedstocks for synthetic chemicals, that's not exploited at all right now. So developing those markets, proving out the applications, I think there's certainly a lot of value there.
Well, thank you all for participating in the session. Very edifying. Please, let's give them a round of applause.
Excellent. That brings us to the end of our formal program. I want to thank first all of our speakers who contributed to the very rich intellectual fabric of the day. Thank you all for coming and participating. And I'd also like to thank all of you for coming and participating in this conference as audience members. And I actually want to do one last thing, and that's invite you all just right outside this auditorium. We have a bunch of posters set up that really show the diversity of work going on here at UC Berkeley. We have 3 or 4 posters dedicated to the education work that's going on, 3 or 4 posters looking at all the catalyst research that's happening, and another 3 or 4 posters that are really looking at integrative projects, things that draw from multiple disciplines to advance our understanding of oil dispersants, of biotechnologies, and we have some really excellent students out there waiting to tell you about their project. So thank you again for joining us today, and have a wonderful rest of your evening.